everyone. Welcome to our fourth and final session for WTM series. So we're very glad to have you here. We thank you for joining us for all the sessions that we've had so far. We hope that they have been very informative for you. As you remember, the purpose of the sessions is to gear you up so that you can be able to participate in the upcoming hackathon, which is this Saturday. So please look at our WTM page and the GDG Nairobi website to be able to register for the event and register your team to participate. So today we are graced by two individuals, two GDEs who have prepared for us two sessions. So one of the sessions will be from Gesa Marvin, who will be giving us an introduction to using LangChains. And then thereafter will be followed by Eric Empire, who will be taking us how to implement this on Android. So I will welcome Gesa to the stage so that he can do the introductory session, and then followed by Eric to be able to do his session. Again, welcome everyone. Oh, and my name is Philomena Mbura, data scientist.
Thank you, Philomena. I hope you can see my screen. And good evening, everyone. Welcome to this session. My name is Marvin Ngesa. And today I'll also be taking you through Gemini and LangChains, of course, building on top of what we've been discussing in our previous sessions. Philomena, kindly confirm for me if you can see my screen.
Yes, we see your notebook. Yeah. Is that what we're supposed to be
All
seeing
right.
right now?
Yes. All right, perfect. Now we've been going through Gemini. We started with an introduction to generative AI and large language models. Then we went into Gemini, how to get started with Gemini. We also went into Google AI Studio and even saw how you could use Gemini with Python. But on top of that, you can also be able to even do more beyond that, because today you can just go to the Gemini website and then be able to search for things on it. But you may want to go beyond what's there on where you usually search to when you want to add more documents to it, or you want it to interact with other components beyond what you're having there. Maybe you want to add agents, send an email, etc. So if you want to get those extended capabilities on top of your model or the Gemini model, then you may want to use this awesome tool called LangChains. And therefore today I'm going to introduce you to LangChains. I have some goals here for the session of the day, where I'm going to introduce you to LangChains, then give you a refresher of Gemini, and then show you how you can effectively load documents and even store them with different databases like ChromaDB, for example. Then after that, we're going to create something called a RAG pipeline, or a retrieval augmented generation pipeline, that will help us to query data from either the PDF documents that we're having, or just from any kind of document you'd want to load and use with Gemini or with a large language model. And if you check on all this, then we're going to have like kind of a 6-part section, where the first one is going to be exploring Gemini fundamentals, looking at what it can do, just a refresher on what we've been doing since the first session, or since week 1. And then I'm going to take you through Gemini fundamentals, or rather LangChain fundamentals, the core functionalities, why we need it, how can you use it to load data, how can you use it to even store information or for information retrieval. Then how do you combine these two? How can you combine Gemini and LangChains together? And how can you be able to use it? And what kind of benefits that does it bring to you? And then, of course, you can just write a chat, or you can just chat with your model. But maybe you can even go beyond chatting with your model, just with text alone, and also add things like images, where you can provide both images and even text to Gemini model, and then it gives you a feedback back to you. And that way, we're going to explore something called multimodal support from Gemini. Then we're also going to go to section 5, where we're going to be able to chat with our documents. I have a document here, a PDF document somewhere here, for Africa Developer Ecosystem 2021. It has a bunch of information about developers. It's about 68 pages. and a lot of content. I think it was a research about developers on the continent. So we're going to chat with this document, and we're going to see how Gemini could, or rather how LangChains can help us to be able to create an or a layer to communicate with a document. And then, of course, the first thing we're going to do is to install the required packages. We're going to install packages like generative AI, the Pillow, the LangChain, ChromaDB. This is a vector database that we're going to use for this particular use case. And then after installing them, of course, I've already run this. I'll also share a link to this Colab. We're going to import some important packages that we can be able to use to display maybe images and even responses we get from our model. Of course, we also have a key for you to be able to use Gemini outside Colab. You'll need to get a key. I have my key that is here already. I've given it a name, and then I have to ensure that it's on for me to be able to use it. So always ensure that this part is on for you to be able to use your model on Colab. Otherwise, it won't be able to run. Then after that, of course, that key will be stored securely on the secrets part for Colab, but I need to find a way to retrieve it. So I'll use this method, user data. So I'll need to, of course, import it so that I can use it to securely get it from Colab. Then also, I need to find ways to show responses that are generated by the model. So I prefer using Markdown. So I'll define a function here that could convert my responses to Markdown, or show responses generated by the model with Markdown. Okay, so on Gemini, of course, we've gone through this in our previous sessions, and you know that it has 32,000 content window. But then there was an update on this one, where today on Gemini 1.5 Pro, you have a context window of more than 1 million tokens. So before you just had 32,000 context window, but today you have Gemini 1.5 Pro that gives you tokens of more than 1 million or up to 1 million. And then, of course, it's free to use for now, but there's some limits, of course, with limits. And it supports features like function calling, like embedding, semantic retrieval, some of them that we had seen before in our previous sessions. And it supports also more than 38 languages. And of course, Gemini Pro accept text as input, then give you text as an output. But Gemini Pro Vision allow you to have both text and image as input. It allows you to have a multimodal support. It gives you multimodal support, where you can provide an image, you can provide a text to it, and then out of it, you can get a text output from it. And we had seen this one on how you can play with it on Google AI Studio and even on Colab. But here, I'll show you how to use it with LangChains. And then the first thing we're going to import, if you're just using Gemini on its own, at least from our last session, if you remember, we had this package called Generative AI, and you can give it an alias name like Gen AI. So you have this package, give it a name like Gen AI. Of course, you're going to import it. Then once you import it, we're going to retrieve the key that we had stored secretly on our secrets, on our Colab secrets. Then once you retrieve it, we're going to create a model here. Create a model. Then we're going to access this class on this package. Then once you access this class, we're going to instantiate it, or rather create an object with it. And then when you're creating the object, we're also going to pass in a name, or specify the exact model you want to use. Of course, there are a bunch of models that you can use. You have Gemini Pro, you also have Gemini Pro Vision, etc., etc. But in this case, we're going to specify the one that we need, which is just Gemini Pro. So once you specify it, you're going to instantiate the class. Of course, the class is in this package. Then that entire object, you're going to save it in this variable called model. Then if you call that model, for example, or if you run the model, you'll see the kind of structure you're having. So you have a model. This is the name of the model. Of course, there are a bunch of other models that you can use. You can see that we also have a configuration here that we haven't specified the configuration, which also you can do. You can also specify the safety settings that you can do as well, and even tools. But here, we just specified the models for using this one here. Then I also just checked on the methods that probably I have on this particular object. So if I check on the methods, I could see that I have a bunch of methods here, including count tokens. You can use it to count the number of tokens you're having, maybe in a statement or in a word. You also have generate content method as well. So I want to try use this one and this one on this particular object. So if I call, for example, here, if I pass in this one called good evening, then I run it. I call this method on the object and pass in good evening as my content. Then it will be able to tell me how many tokens I'm having in that particular word. In this case, I only have 2 tokens. But beyond this, I can also call other methods. And one of the other method I can call is generate content. As you can see here, I'd log in all the methods that I have on the object. And if I check on it, then you could see that I have my object, and then I can call the method. But when I call the method, I need to pass in the prompt, what guides the LLM, or what asks the questions to the LLM. So, for example, here I have what advice will you give to other women who are just starting the journey in tech? So, it's just like a list. Then I pass in this one, save it, save the list on a variable, then pass it here. Then I also want the answers to be in. I want the answers to be in Markdown. So I want to convert it to Markdown. So if I run it, and then I get the text part of the response, I can access the response on as a text. So if I do .text, then I'll be able to get a feedback from it. It will give you feedback like embrace the learning curve, build a strong foundation, join communities and networks. Remember, the question was, what advice will you give to women who are just starting the journey in tech? Find mentors and role models, be persistent and resilient. So at least it gives you a feedback from what you're having. And this is what we discussed in, I think, in the second week on how to use Gemini. But this one is just Gemini on its own, from Google.generative AI package on its own. So we're going to move from this point and then go into LangChains. And like I told you may just want to go to Gemini online and search something, but you won't have more capabilities with just what you're doing, because we just be searching, maybe writing a statement then getting an answer from it. But if you want to work with documents, if you want to work with databases, if you want to split this document into chunks, you want to have more capabilities beyond just the typing that you usually have on Gemini on the browser. Then you have a nice tool called LangChains that can allow you to do that. So LangChains come with a bunch of tools, and it can allow you to build applications on top of large language models. Means just any large language model that's probably available, be it from OpenAI or from Hugging Face. You can be able to have them and use them. And that means that even the code that we have here, what you need to do is just to change the large language model that you're using, if you want to change the large language model. So large language model help you to create data-aware applications, and also it basically allow LLMs to access information from different files, from different applications, and give you a richer context compared to what you just have on what you usually access on ChatGPT or on Gemini platform. Then, of course, it has a bunch of components. It has things also called chains, where you can make a sequence of calls, not just one calls alone. You can chain calls after one another together. And then it also has a wide community today. A bunch of guys are downloading it and are using it. And that means that if you are stuck somewhere, it's very easy to get a solution, because a bunch of guys are also trying the same thing. So it has a very huge community. So that's why it's one thing that you may want to try. But it has components. It has components like document loaders. It can allow you to load different kind of documents, PDF, for example. Then once you load this document, for example, this one here, you can also be able to split the content into different chunks, or into different splits. So it has something called text splitters that you can use to split those documents into different groupings, so that you don't necessarily have to put the entire document into it. So you can split them and then maybe save them in a vector database, which I'll show you. Don't worry about that. I have like a nice diagram that I'll show you on it. Then it also has the models, the GPT, the llamas, the Gemini that you can use. Then it also has natural language retrieval. It allows you to be able to extend the capabilities of a large language model and then give you response in form of natural language. So that's so that if you ask a question, you can be able to get the response in form of natural language. Then it also has things like memory, if you don't want to hold memory. It has text embeddings like Google embeddings, vector stores. In this case, we're going to use ChromaDB. In fact, I have a diagram here that I can show you on probably what you're going to try today. Today, we're going to have like a PDF document somewhere, and then that document, the document I've been showing you, this document here, and then that document, we're going to use data loaders from LangChains to load that PDF document. Then once we load it, we're going to split that document into different chunks, different text chunks. You're going to split them into different text chunks because sometimes not all the content in the PDF documents you're having, maybe one document or several documents, can be able to fit into the large language model. Remember, the large language models have a context window. You can have a 32,000 context window for Gemini. Right now, Gemini 1.5 Pro has like 1 million context window, but assume that you have like lots of PDF documents or lots of data that probably may not be able to fit in that context window. So Gemini will allow you to load the document, then split them into different chunks. And then once you split them again, you can be able to use maybe Google embeddings to convert all those chunks into embeddings of chunk. And then that way, you can be able to build like a semantic index and then store them in a vector database. For example, ChromaDB. So in this case, we're going to use ChromaDB. Then once you've done that, this could be like the first part of it: loading documents, loading, splitting them into chunks, and then converting them into vector embeddings, and then storing them somewhere in a database like vector store. Then once you've stored them, you may have like a second part of it here where a user can be able to ask a question. Then the question can be converted into embeddings, then semantic search, and then you will be able to ask questions from the vector store. Then you'll get like a bunch of responses, ranked responses. Then those ranked responses, you can be able to leverage on LLM so that you can get answers in form of natural language. Okay, so this is how the architecture looks like of what you're going to implement. But first, maybe we see the implementation of LangChains together with Gemini. So the first thing you'll do is that you'll have this package. And then from this package, you can now import this class, Google Generative AI class. And then that class, you'll just do the same thing like the previous one, where you'll instantiate that class. You'll create an object with that class. So create an object, but when you're creating the object, you need to define the model you're using. In this case, Gemini Pro. Then define. You can pass in other arguments like temperature, for example. Temperature give you can allow your model either to be deterministic or to be more creative. If you want your model not to be creative and just give you almost similar answers over and over again, then you can have a temperature closer to 0. But if you want your model to be more creative and give you answers that are varying from one point to another, then you can have a temperature that's maybe close to 10. Then of course you'll have to pass in your key. Then after that, you'll have an object. You'll have created an object of the large language model or of Gemini. Then you can store it in a variable. Give it any name like LL model, for example. Then once you have this one, LL model, of course, that object has a bunch of methods. One of them being invoke, that you can call on the object, then pass in the question or the prompt that you're having. Then once you pass in, then you can get results from it. Then that results, you can print it and see what it has. For example, if you put what is the meaning of matatu culture, then you print results. You can take that text you're having, leverage LangChains to give you access to the large language model, in this case Gemini Pro. Then once you have access to Gemini Pro, then your question is going to go to Gemini Pro. Then Gemini Pro give you an answer from it. For example, here you can see matatu culture refer to the vibrant and unique subculture surrounding matatus, privately owned minibuses that serve as a primary mode of public transport etc., etc. Then it can give you key characteristics: colorful, extravagant decorations, loud and energetic music, personalized interiors, social hubs, cultural experiences. Then it gives you also significances, economic importance, cultural identity, tourism, etc., etc. So it means that here we're not just going to the Google AI package directly. We're just going to LangChains, and then LangChains we're going to use this class from it, and then this method, I mean this question can be passed to the Gemini model via LangChains. Then now you can be able to use it. And then also, you can use things like prompt templates as well. So Gemini, apart from just the documents, the splitters, and all that, it also gives you things like prompt templates. And prompt templates, they can help you to format the input. Case in point, if you if you want to provide, let's say, more context to the model, or more context for user, so that you get like a better response, then you can be able to use prompt templates. For example, here I can do the same thing, just create an object of the large language model, of course, passing in the model that I'm having, passing in a temperature, and then passing in the key that I'm using. Then that object, save it in this variable called LLM model. Then I could also just call this invoke method, then pass in the prompt that I'd want to use. So I can do this, then pass in on it. But maybe I want to be able to be more dynamic and try to change things like this Swahili food, so that I can change this and have different kind of type of food. Maybe I want Ugandan food, maybe I want Rwandan food. So how can I be more dynamic, and even change the context of the questions I'm asking? So here I can be able to get the prompt template, create a template with it. For example, here's my template. I want to open a restaurant for that particular type of food, then suggest a name for it. So I could change this and make it an input variable here. So I can define an input variable. Then I can create my prompt, and that prompt I could be able to pass in the template that I've created already. Then there's this method called from template on prompt template. So I can call that method, then pass in the template that I'm having. And then here I can have the type of food to be Baganda, or maybe the other one was Swahili. So here, for example, is Baganda. Then when I print it out, the one that's formatted, I could see that now I want to open a restaurant for Baganda food, suggest a name for it. That means that I can be able to change this one to whatever I want, be it Western Kenya, be it Canada, be it South Africa, and then I'll be able to have a formatted prompt at the end of it. And then I could use something called chains, and then combine the prompt that I'm having together with the LLM model. And at this point, now I can be able to generate text using that chain that I'm having. So if I print it, I can now print the one for Baganda instead of the original one. It means that I can be able to tweak or change the inputs with the prompt templates the way I want it. And you could think of prompt templates, for example, as someone trying to tell a story to someone trying to ask a question from a friend. But before you ask a question from a friend, you first of all give them a background information. So you can imagine that you're talking to a friend who's new to maybe a particular topic, maybe to at a particular topic, and then you start by explaining things with some background information to help them have understanding of what you're trying to tell them. So here's another example where I can give a template where you say, maybe as a developer in Nairobi, I often find inspiration from maybe street location. Maybe can you help me craft a code snippet that can capture the essence of a particular topic? So this way, you're already giving a background. You're already trying to give a background information to the model that you're having. You don't just going to ask a question to the model directly, but you can have prompt templates that gives background information or some kind of history to the model that you are having. So if you do the same thing to it, where you combine the prompt with the large language model, of course, this prompt already have the prompt template. Then now you can change the location here. You can change the location here CBD. Then you can also give it a different topic that you want. For example, efficient traffic management. And then on the response, if you can call in this invoke method and then pass in a dictionary with the location, of course, location that you are having, and then the topic that you've given it. Then if you print a response, it will be able to give you a response. So you can be able to tweak this one the way you want. You can be able to change in the template the way you want, and then it will give you different responses from it. And that's how you can use a prompt template with it. Then you can also be able to do streaming. And LangChains allow you to segment the prompt that you're having into 3 different types. You have system, you have human, you have AI, and all this can also give like a background information to the input. So human represent the user input that you're trying to give it, and then AI, it shows the response of the AI model that you're going to have. So here you from LangChain schema, you can get all those segmentation prompts that you may want to have, and then you can again from this package import the class, then have a high behavior of how the model should behave, and then you can create your chat model the same way you're creating the other models. You just instantiate the model, instantiate the class, pass in the model name that you're having, pass in other arguments like temperature, and then the key, and then you create your prompt. That prompt you can be able to kind of simulate the conversation out of the high level behavior that you're having here. For example, this one, I'm a travel assistant in Kenya, ready to help you discover your next adventure, maybe in Kenya. Tell me about your preferences, interests, and budget, and I suggest 3 exciting destinations with a brief description. Then here, as I message, hello, I'm your travel assistant in Kenya. Where would you like to go next? Then on the human message, you can say, maybe where should I travel next in Kenya? Then once you do that, it will be now be able to give you a response. I think I have response here. You can print the response, then it gives you response. For example, here, ascend to the summit of Mount Kenya, the second highest mountain in Kenya, trek through, etc., etc. It gives you Lamu Old Town, then a description of it. It tells you Nairobi, give you a description of it, different places. And you can also tweak the high level behavior, the AI message, the human message, and then you'll be able to get different responses from the combination. You can even tweak all this and then have the message come in chunks. Instead of just having all the message come to you at once, you can decide to split all of them into chunks so that you get different chunk messages from it. Okay. And that way you'll be able to stream messages from the response that you're having. Then the next one is multimodal support. And multimodal support is where you can combine both the Gemini vision part and the text prompt that you're having. Then a combination of the two, you can be able to send them to Gemini, and then you'll have response in form of text. So here I have an example. I have this image path. I think it was an event in South Africa or Johannesburg for women tech makers. Then I can be able to get the message and load it here on my Colab. So if I load it, this is what I get. Then once I load it, I can decide to create a chat model with it. And then when I instantiate this chat model, I can pass in the Google provision model and then the key to it. Then on this message, if you see on the context, the human message I'm passing to it on the context, you can see I'm not just passing in like one type of it. I'm not passing in just the text on its own. I'm also passing in the image. So the type you have text, I have like a list of dictionaries. So I have like a first dictionary here with text. And then I also have the prompt itself. For example, the type, which is text, then the text itself, I have a prompt on it. For example, here, what do you see in this image? Then write a detailed article based on this image. So that's the first dictionary. Then the second one, I have an image type here, which is an image URL. And then I give it that image that I'm having, the image URL, which I already have here, this URL. Then when I give it the image, I can now call the invoke method on that large language model, then passing the message, Of course, all this was stored in this thing called message. So if I call it, I can convert my output into Markdown, and this would give me this kind of response. This image shows a group of people in a room. There's a woman standing in front of the room speaking to the group. She's using a projector to display a presentation on the wall behind her. The projector displays the words International Women's Day Celebration. There are people sitting in the chair in front of her, listening to a presentation. There are also people standing around the edges of the room. The room is decorated with a few Google banners. Yeah, so as you can see, it's almost what the description is almost what we can see here. Okay, and that way you can be able to use both text and images and send it to the model using of course via LangChains, and still be able to use things like human messages and passing to the model. Okay, let me go to the next one. And then, if you remember, our first model didn't have like safety settings. Also, you can still be able to also add safety settings to your Gemini model. For example, here, if you remember our first model, we didn't have this one here. We didn't set anything on the safety settings. So in this one, you can see that we've been able to be able to block to have a threshold on harm block content. So I can be able to instantiate the things I don't want to block, like harm block threshold and even harm category. Then I instantiate my model. Then when I instantiate it, I can now pass in the model that I'm using, like Gemini Pro model, and then pass in the key as a second argument, and then now pass in my safety settings. So like you can see harm category, then I can define the threshold that I'm having. For example, here block none, but this can be changed to whatever whatever level you do want. And that way, if I call my LLM at this time, you can see that at least the safety settings have now been configured, and I already have this the same way I had the other one. You can see the general configuration there's nothing in it still, but now I've been able to change the safety settings on my model. Okay, then the next one is chatting with the documents. So I'm going to show you how we can be able to interact with this particular PDF, and how we can leverage on Gemini on LangChains to load the PDF to us, split this content into different splits, and then store them in ChromaDB, then ask questions from the document. So I have this similar architecture, the one I showed initially, where we have the PDF, the one I've shown you. Then we use LangChains to load the document. It does things like document loaders. And then we're going to split the document into text chunks. Then once you split it, we're going to use embeddings, Google embeddings, to convert those text chunks into embedded chunk of text. Then we're going to build like a semantics index, store them into a vector data store, to a point where if we ask question, we can be able to ask question, convert it into embeddings, then ask question from the vector store, get a list of ranked results, and then leverage on top of or extend the functionalities of the large language model to give us answers from it. Okay, so of course the first thing is to install the necessary packages. Then we're going to use document loaders, one of them called PDF loader, because we're going to use PDF. This one is a PDF document in this case. Then we're going to split the text we're going to get from this document, because probably all the words in the document may not be able to fit on the context window that we're having for the model. So we're going to split them into chunks. Then we're going to save all those into a vector database. In this case, we're going to use ChromaDB, but there are others like Fize, there's Pinecone, a bunch of them. Then we're going to use chains, which is a sequence of calls to ask questions on the documents. So to do this, the first thing you need to do is to import this class from this particular package, instantiate our model, save it in this variable called model. Of course, specify the model we're using, specify temperature. You can always tweak this the way you want, depending on the kind of answers you need. Then pass in the key that you're having. Then once you've done that, we're going to load the document and store it somewhere on our load the document and store it somewhere on our collab. So for example here, I'm going to specify the path. You can see kstatic, whatever. That's the path where this document is online. And then this is the URL to the document that you're going to save here, the PDF file or URL to the document you're going to save. And then after that, I'm going to load the document. For example, your PDF loader, load the document, passing that particular URL to it, the path to the document I'm having. Then once I load the document, I can call method like load and split so that I can be able to split the documents. And if I check the length of pages, you can see that I have 68 pages from that particular document. Maybe you could check and just confirm. This is the document I'm having. It's saying it has 68 pages. So yeah, you can see that we have the correct document. You can also see the different content on different pages. For example, here you may want to see content on page 2, content on page 3, on other pages. So if I print content on page 2, you can see Africa Developer Ecosystem 2023, a bunch of information. Let us see if that's what we're having. Page 2. Let's see. Which one is page 2 now? Okay, page 1. Yeah. You can see Africa Developer Ecosystem 2021, report methodology, forward. Let's see if that's what you're having. 2020. Let's see. Okay. You can be able to extract some information from it. Then you can also even check the number of words you're having on the document. So yeah, context, total number of words, length of context. You can see this number of words I'm having. And they're saying that one token is about 0.75 words. So you can be able to convert the number of tokens to the number of words and see if those number of words can fit into your particular context window. Then at this particular point, you can also be able to define a prompt template that you want. For example, in this case, answer the questions as precisely as possible using the provided context. If the answer is not contained in the context, you can say this particular word, then you pass it there. So these are prompt templates. Then you can instantiate the prompt template from LangChains template, then pass in that prompt template you've created. You also have input variables here like context and questions, which you can always change. Then you could call in the load QA chain method, class, instantiate it in this particular point. Then you can pass in the model, pass in the chain type, then the prompts that you already have here. Then you will have the question that you want to ask. And then if you pass it here and you print it, you can be able to see. It can tell you if answer is available or not. For example, in this case, it's telling me that answer is not available in the context that we're having on the particular page 5. I mean, between page 7 to page 10. Then you may decide to change the pages again, maybe from 0 to page 50, and ask the same question. For example, what are the challenges? What are the key challenges facing developers? But I want the answer to come from between page 0 and 50. This one I limited to page 7 and 10, and it's saying that between 7 and 10, it doesn't have the answer in that particular context. But I can change the number of pages to go to 0 to 50, and only give me answer if this question is true. If not, don't give me that particular answer. Okay, if I do that, then I can be able to, you can see that I can get answers from it. You can see now I can get answers because I've increased the number of pages, and the question I'm asking is that particular number of pages I've selected. So you can see the key challenges facing developers are lack of training of companies. Many junior developers are facing challenges in transition into mid-level and senior roles. Junior developers lost access to major training. Women developers are facing more challenges than men. Maybe we could check if that's true on this document. Key takeaways, page 7 to 10. This is 6. Let's see.
You have received a reverse call request.
I'm on a call. I'll call you. I'm on a call.
You see?
Size yetu kidogo.
Ningoja muda
Okay, let's check it here. I could search here maybe challenges. This is page 35, education and access, key challenges facing developers. I think is in page 36. Let's see. Yeah, and you can see that where there's no summary. Lack of training that accompany remote work, soft skills. You can see the challenges are here as well that they're giving us. Okay. Then beyond this, you can also implement, you can also take this data to ChromaDB and even ask those questions. So, for example, here, I can do the same thing, get generative AI embeddings. Then from this one, access this embedding from Google. That embedding is going to help me convert these text chunks into embeddings of chunk one for this chunk system. Looks like in Kenya. Then the vector, I pass it here. Okay, if I pass in, for example, this kind of text, and I can use this embedding 001 to convert this text into embedding. This is what I'll get from it if I pass in it. If I check on the last one, these are the last 5. These how the embeddings would look like from this particular content. I can also check. All right, so I could go ahead and then split use this thing called recursive splitters from LangChains, splitting my entire document into chunks of chunk size 5,000, and then I can also get text from it on the content. Just give me a minute. Just a minute. Okay, and then I can store all this into ChromaDB, the text and the embeddings, so that if I ask her questions if I ask a question on the document that I'm having, I should be able to get an answer like this one, for example, on the diagram. If I ask the question on the chunk that I'm having, I should be able to get an answer similar to this one here. That I'm getting from the vector database. Okay. So again, we've been able to have some PDF documents with the help of LangChains, be able to load the document. Then after loading it, we've been able to convert or split those words into chunks using text splitters. Then those text chunks, we've been able to use embeddings and convert them into embedding of chunk, then eventually store them into a vector store like ChromaDB. And then we've been able to ask questions where these questions are converted into query embedding. And then we have semantic search on the database or on the vector store. And then we'll get like rank answers from the vector store. Then we leverage on LLM or extend the LLM to be able to give us answers from the vector store in the form of a large language model. Okay, so I think that's the end of my presentation, unless any one of you has questions. All right, let me check if there is any question. Let me see here. Hi from DRC Congo, that's Yves Kalume. I can also see Jakim Mora, Nairobi, Kenya. King Brian, I'm joining in from Nairobi. Ian Owor, I'm joining in from Nairobi. Brian Rotich, joining in from Mongata Rongai, Cindy, Kenya. Then there's a question here. I think it's from Moses. Let me just load it. Can I use LLM Vision to caption more than one image in a folder? Also, can they touch on the best way to associate the image? And okay. Can I use a LLM model to caption more than one image in a folder? So I'm yet to use the LLM to caption more than one image in a folder, but I've tried it on just one one image. Maybe we could try it and see if it's possible. But I know you could pass in one image together with a prompt, or together with a text input. Then the text input and the image, you can get an answer from it. I've never tried to, but I think it should be possible. I know it's possible on what? On Google AI Studio. So on Google AI Studio, you can load an image, then ask questions about it, and maybe load another image on it. But I've never tried it on Colab, for example. Then kindly touch on the best way to associate the image and the description. All right. So let me go back to my presentation. Share screen. So I want to go back to the presentation. Here, for example. Why is it? So on the multimodal. All right. So here, I have an image on this particular URL. Then this image, I can be able to use a Python to display it on my Colab. You can see here I have it on the Colab. Then once I display it, I also have the image URL. This is the image URL, and you can clearly see that the URL is here. Then if I go down, I can be able to, from LangChains.com messages, I can import the human messages. Then from this package, I can also be able to get this particular class so that I can chat with the model. And then this way, I can now instantiate the chat Google Generative AI class, pass in the model I want, for example, the Gemini provision in this case, because I want to interact with images. And then on my message, I can instantiate the human class, then pass in the content that I want. But in this content, you can see here, I'm passing two dictionaries. This one and this second one here. In this first dictionary, I will have a type of text. So I'm having a type of text that's going to go to the model. And then you can see the text that I'm having here. What do you see in this image? Write a detailed article based on this image. Then the second one, I'm going to have an image URL, the one I showed you, as a type, then passing that image URL. If you go back here, you can see that it's what I'm having here, the URL that I'm having. Then when I pass in the two are going to be combined together to form this thing called the message. So this is a message I'm going to send to the large language model. I'm going to send in the text, a combination of both text and an image. And then when I call in the invoke method on the large language model, I could now pass in that particular message that I'm having. And then that combination, of course, is going to go back to large language models, to LangChains. Then LangChains is going to check the kind of large language model I'm having, which in this case is Gemini. And then Gemini will give us a feedback. And that feedback, I can access it from this content. So if I do the results with content, I can now get the results from it. In this case, the image shows a group of people in a room. there's a woman standing at the front of the room speaking to the group. And if you check on it, you go up here and check on it, you could clearly see that it's giving a response about the particular image. So in this case, you've been able to pass in a text, and then pass in an image. But I think this thing should allow you to pass in more images. Maybe we could try. Let's see. I could try passing another image. Which image should I look for? Let me look for GDG. Wait, I think this is going to take me to a bunch of things. I'll just do it, then I'll share it online, because I'll need to download the image, etc., etc. I hope I answered your question. Okay. All right. So if there's no any other question, then I'd want to thank you guys for joining. And I want to hand it over to the next speaker, who is a Google developer expert for Android, joining us all the way from Canada. Hi, Eric.
Hi, Marvin.
Yeah, in Kenya we say karibu sana. So welcome to welcome to us.
So, hello everyone. So my name is Eric. In today's session, so it will be kind of the presentation of what Marvin had just explained. We'll try to implement everything that you have tried to say, but on the Android side. So I'm not gonna try to implement basically everything. We will try just to give some foundation that we can use to get started using LangChain with LLM in Android. So as you can see from the title of this session is LangChain use the power of LLM in Android. So like I've said, my name is Eric. So I'm a mobile developer. I'm also part of the Google Developer Experts in the Android category. So currently I'm working as a mobile developer at Bombardier Recreational Product, also known as BRP. So BRP is basically a Canadian-based company. So we are basically building recreational vehicle, if you just want more clarification. So those kind of vehicle, and then most of the time we used to work on the system that is supposed to help the user to be able to use those kind of vehicle in the best way possible. So if you want to reach out to me, you can just scan this QR code. You will have access to all of my social media links. So feel free to reach out to me, ask any questions. So if I will just try to create a time to answer to your question whenever possible. So what is LangChain? I think Marvin already tried to explain it already in the previous session. So LangChain is basically a JavaScript and Python framework that help you to build complex application that take advantage of LLM. So it has been basically created in JavaScript and Python, but in this session, we are going to try to see how we can take advantage of that framework on the Android side. So the main goal of LangChain is to simplify the creation of application using large language model, like Marvin just explained, and it's fully open source. So you can find it on GitHub, you can download it, contribute whenever you want. So it's a pretty interesting project. So why would you want to use LangChain? So there is a bunch of reasons. So I think Marvin also take the time to explain some of the reasons that we can have when it comes to use that can make you use LangChain in your application, but I will try to point out some of them. So the first one is the fact that LangChain had a layer of abstraction of many APIs. For example, as we are going to see in a couple of moments, so LangChain create a abstraction on top of different kind of LLM, right? That it will allow you to be able to create complex application by combining several LLM into a single application, as you are going to see shortly in the demo. Another key advantage of using LangChain is the fact that it gives an easy integration of those API to build more complex applications. So, for example, let's say you want to create an application that will take advantage of Gemini, or let's say GPT-4 or any other kind of LLM, right? You can use that by using all those APIs separately. So, which mean you can use the Gemini API, you can use the GPT API, and try to combine those API together in order to take advantage of each of them. But if you want to do that process in the easiest way, you can use LangChain. We are going to see that in a couple of moments, the way that LangChain can help you to integrate those LLM API easily and to build a complex application. And another key advantage is the fact that LangChain give us a lot of tooling that can help you to build your application much more faster instead of being stuck of different kind of API, different kind of implementation in order to make them work together. So that was it in my presentation. So now I will try to switch to Android Studio. So I hope you guys can see my screen. Okay. So now we are in Android Studio. So I have already created the project. So it's a pretty simple project, right? So I will try to launch it so you can see what we are trying to do, just to demonstrate the basic of what we are going to build today. So as you can see, it's a pretty simple project. So we have a text field here. So the idea here, we can be able to fill up a message here, and we'll tell the model to give us some response related to that. So as you can see, there is nothing working so far. So the idea here, we'll try to demonstrate the way that we can use LangChain to combine different LLM, right, into a single application and to take advantage of all of them. So right now, the first thing that we need to do is to add the dependencies. So like I've said earlier, so LangChain is available in Python and JavaScript. So in order to be able to use it to an Android project, we need a library or a dependency that is compatible with Java or Kotlin. Thankfully, there is a library called LangChain 4G. So it's a Java implementation of the main repository that we have in Python. So you will need a bunch of dependencies. So we will need this main one. So if I just click on it, you will see it's dev.langchain.langchain4g. So if you need to use OpenAI API, you will need also to add this LangChain OpenAI. If you want to use Vertex AI for Gemini, you can also add this dependency. If you want to use another LLM, so for example, here Mistral AI or Olama, so you can add all those dependencies to take advantage of all those LLM. So in my case, I will try to combine three of them, right? So in my single application, I will try to take advantage of all those three LLMs. So we'll try to use the Mistral AI, Gemini, and OpenAI. So after that, you need to have the keys, right? So we will try to use the Mistral API. We'll try also to use the Gemini API and the OpenAI API. In order to have access to those API, it's very important to have the key. So in order to have, for example, the key for, let's say, Gemini, you just need to go to Google AI Studio. You can generate your key and put it in your projects. So in my case, I've already created a class, right, that I've called API token. I have my token here. The first one is for Mistral AI. The second one is for Google AI, and the last one is for OpenAI. So after that, what we're going to do is, so for example, I want just to showcase some key advantage that we can use with LangChain. So let's say I want to build an application that will take advantage of all those three LLMs. So for example, I want to take advantage of the image generation from OpenAI, the text generation from Google AI, and another feature from Mistral AI. So the idea behind those kind of application is being able to take advantage of each LLM. So for example, we all know that all the LLM that we have so far are not the same. Some has a lot of advantage when it comes to generate images. Some other has a lot of advantage when it comes to generate the text or whenever. So in this small session, we'll try to see how we can combine all those things in order to be able to take advantage of this. So I have a simple Jetpack Compose UI, as you can see here. So let me just put my phone in. Great. So we have a simple Jetpack Compose application. And in this application, we have this summary screen. As you can see, we have a column. So pretty basic stuff, right? We have here the selector, right? It's basically a drop down that will help us to switch from one LLM to another, right? And here we have a AI selector. It's just a Jetpack Compose drop down that I have created, and we have here a text field. So something relatively simple. So this session is not about a Jetpack Compose. So we will try just to focus about how to integrate, how to take advantage of LangChain and combining all those LLM into a single application. And there is also a view model, right? As you can see, it's relatively simple, right? Every time we click on this go button, we must submit the text that user just entered to the view model. And this view model must be able to submit that information to our model, and the model can be able to process that and give us an answer. So let's jump into that. First thing first, we need to create an instance of our model. So in my case, I'm going to create 3 of them. So the first one I'm going to create is let's say I can say OpenAI model, right? And I can do something like OpenAI chat model. So I've already have the code here. OpenAI chat model. You can just copy past it, and then I will try to explain it. So as you can see here, we create these objects from the OpenAI chat model, and we call the builder. The first thing that we need to provide is the API key, because we'll need to have access to the API of coming from OpenAI. So secondly, we need to specify the model that we're going to use. So in this case, I'm going to use the GPT-4 Turbo, the preview one, right? I can just use the GPT-4, but for this one, I'll just skip the what we have. I will create another one. So let's say Mistral the same way. I need to specify the API key. I already have the token, and then I can build it. For this one, I don't need to specify the model because it will use the default one. So I'll just stick with these 3 for now. Secondly, the next thing that I need to do is to try to create a way of switching from one model to another one. As you can see, I have said earlier that LangChain help you to have an abstraction on top of different kind of LLM. As you can see, I have been able to create the model object using the same structure, right? So it's basically the same API that has been created on top of the OpenAI API, and the same thing has been created for Mistral AI. So here, as you can see, we have this drop down, right? And every time I click on it, I can be able to select one model to another. So I can switch to the OpenAI one, to Gemini, or Mistral AI. So to do that, there is this method here that is called every time I select one model or another one. And every time we use that, I'm just update the UI state of my application to set the selected model. As you can see, there is this summary states. Basically, it's an object that represents the states of this UI. As you can see, we have the selected model. By default, there is Mistral AI. I've just created this anim class, right, that we can use to represent all the models that we have on in our application. And we have also this previous prompt. So for now, it's not necessary to try to understand what this field will help us for. And the last one will be this loading state. Basically, it will be a class that we'll use to track the progression of our requests. So let's get back to the view model. As you can see, the OpenAI or the Mistral AI use the same API coming from the LangChain, right? And here, in order to be able to use the OpenAI API, I could use their own API, but I'm not sure there is already the OpenAI SDK for Android. I'm not sure. I haven't searched for that. But at least I have an API that I can use directly from LangChain in order to be able to interact with the OpenAI API. And here, since I have this model, in order to be able to search for something or to request to this model, I can just use something like this. So for example, Mistral AI, generate, and I can pass just this input text, and that's it. As you can see, I've been able to interact with the Open AI or the Mistral AI in just one single line. Let me just try to run this application and see what's gonna happen. So my application is running. It's taking too much time. I don't know why. Let me restart it again. Okay, let me try to uninstall the app and try to install it from scratch. What is the name again? I think it's Demo AI. Uninstall, and let's try to install the app from scratch. Here we go again. The app has finished installing. It's launching. Okay, so we have our application. So I will just try to ask to the AI, to the Mistral model, something simple. So for example, what is the tallest building in the world? So if I do that, let's wait for the response. Taking too much time. I don't know why. Okay, I think there is a simple reason that this is doing this way. As you can see, I forgot just to update my UI state. So what I need to do is to get the response coming from the model, and then I need to pass that response to my screen. So here I can just use loading states, success, and I can use response, right? Let's try to run it again. So as you can see, it's just something simple. This generate method will create a request to the Mistral AI model and try to give to that AI, to that LLM, the request. Let's do the same thing. What is the tallest building in the world? Let's go. And as you can see, as for now, the tallest building in the world is the Burj Khalifa in Dubai. So right now, I've been able to send my prompt here to the Mistral here LLM. I can just switch from one LLM to another by just changing this Mistral model by this OpenAI model. So let me try to do the same thing. As you can see, it's just simple. So let's try again. I will ask the same question and we will see the response will be quite different because OpenAI and Mistral AI are different LLM. And as you can see, we have been able to switch from one LLM to another as quick as possible. So while the application is starting, I will try to create, let's say, an hash map, right, that can help me to switch easily from one model to another from the UI. So let me ask the same question to GPT-4. What is the tallest building in the world? And as you can see, it gives me the same answer. So I will just create a hash map quickly, right? So for example, I can say models hash map, and that hash map will be the combination of model and the name of the model and the model itself, as you can see here. So we have the model enim that is matched the OpenAI model, and the Mistral enim is matched to the Mistral AI model. And here in my screen, instead of using this hard-coded model, I can just get the selected one. Selected model, I can use the hash map model and do something like this, right? This hash map will return the model that is associated to the selected one, and I can just use the selected model generate. Since this is nullable, I need just to wrap it. Selected model, let's, and I can use this. Let's remove this, and let's see what we are going to have. So that was the simple use case that you can use with LangChains. So it's help you to combine several models, several LLM into a single application at ease, like you can see. The next example that we are going to see is building a context-aware application, as we are going to see in a couple of moments. By default, every single LLM doesn't track the context of the conversation. So for example, here I can ask the question. So for example, what is the tallest building in the world? I will ask to the Mistral AI LLM. Let me switch to the OpenAI and try to ask the same question. Okay, we get the response. And I will try to ask a follow-up question. So for example, convert it's, for example, let's say height in kilometer, for example. As you can see, the response that has been returned doesn't relate to the previous question, or the most of the time when you are discussing with the LLM, the natural behavior is being able to have the impression that it's something conversational. So it means that the AI must be able to understand exactly what you are trying to ask him to do and what you are trying to accomplish. Before doing that, I will try to ask him to explore some other feature related to LangChain. So for example, here, something that Marvin explained is the ability to segment the prompt. So for example, here I can have something like user message, right? This can be represented, can represent the message coming from the user. And I can have something like, let's say, system message, right? And as you can see here, I have two messages, right? It's the one coming from the user and the second one coming from, let's say, it can be considered as the system message. And as you can see here, I have provide, let's say, a context. So I'm the king of the UK, talk me with respect, right? And I will try to call this generate method using those two fields. So for example, the user message and the system one. So to get the response, I need to call the content.text. Let's try to ask this and we'll try to see what will be the difference. This one has been able to segment the prompt, right? So the user will send this initial prompt, right? But the response that we will have from the LLM will depend on this one. So the way that the LLM will respond to me will try to match exactly what I have tried to define here. So for example, here I can try to ask the same question. What is the tallest building in the world? Let's see what will be the response. And as you can see, the phrase starts with Your Majesty. The current tallest building in the world is the Burj Khalifa. As you can see, we have been able to provide more context to the LLM, and the LLM has been able to give more insight about what we are asking for. And this will work the same thing if I switch to OpenAI. And you can see it stands high. So it seems like for this one, it doesn't work. I don't know why. I don't know, maybe there is a problem with the way this is working, but the idea here is being able to segment your prompts and being able to track what we are doing. So for example, let me try to ask another question. Let's say, who painted the Mona Lisa, for example? The Mona Lisa was painted by an Italian, Leonardo da Vinci. I apologize for misunderstanding and provide information respectively. So those are the response that I'm getting from the LLM. And I will try to ask the follow-up question to illustrate the next point. For example, here I can ask the follow-up question: where can I see it? As you can see, it say, "I apologize for the oversight. How can I?" So the LLM has not been able to provide me the current answer. But as you can see, it finished the phrase with Your Majesty because of this context here that I've provided, right? It's make the AI to get more context of the way that it should respond to me. But how can we solve the problem of the context, right? In order to do that, we are going to use the chain operation that Marvin explained earlier. In order to do that, I need to create a memory object. The memory object will be responsible of memorizing the conversation I'm having with the LLM. And to do that, I'm going to use the memory object, memory windows, and I will define the maximum message of 10. And then here, I will try to create the chain objects. Basically, the chain object is responsible of chaining all the question, all the conversation that I'm going to ask to the LLM. And here, instead of calling selected model dot generate, I will just need to do something like chain dot execute, and then I will give that input message. So let's see what's gonna happen here. The response, it's the text. Let's see what are we going to have. So basically here, I will create a model. So I will provide more context to my LLM, right? And it can be able to respond to the follow-up question that I can ask related to something. So basically, I will have a natural conversational chats as we used to have with ChatGPT or any kind of modern LLM. So let's ask the same question. Who painted the Mona Lisa? As you can see, I get this question. Let me try to ask a follow-up question. Where can I see it? Okay, as you can see here, you still don't able to understand exactly the context that I'm switching. I'm asking. That's why I was able. That's why I added this property here. Next prompt. So basically, what we are going to do every time we ask one question, we are going to save that question to the state of the UI that we are going to use for the next it will be used for as a context for the next prompt. So for example, here I can use something like let's say UI copy. So I can just copy past the code that I already have. Where is it exactly? Okay, I can just copy this one. Right. So what we are going to do basically here is if the previous question is not empty, I will basically chain it to the context of the LLM. And here I'm just going to create that variable, right? And here I'm going to be using this execute method to get more context about what I'm asking for. Let's jump in and try to see what are we going to have. Okay, let us ask the same question. Who painted the Mona Lisa? Okay, this is the answer. Let me ask the follow-up question. Where can I see it? I still don't able to see the context. Maybe there is something that I haven't done properly. Let me just check a little bit here. Previous question, chain executes. Yes, that is what it should be normally. Let me try to switch to another model. Let's say OpenAI. I think I know why this chain is not getting executed. The idea here, if I execute, I must save the previous question to the previous one in order to be executed when I will ask the previous question, the next question. Let's see, what are we going to get? Okay, so who painted? The Mona Lisa. Okay, I got the answer. Let me ask the follow-up question. Where can I see it? Okay, as you can see, the model has been able to catch up the context of the conversation. As you can see, the Mona Lisa is currently housed at the Louvre Museum in Paris, France, blah, blah, blah. So this is the way you can use a LangChain, right, to memorize the conversation that we are having with the current model. As you can see, all these operations are independent to the model you are using because as I've explained earlier, the idea behind LangChain and the other benefit that Marvin explained is the fact that you can be able to use just the abstraction that LangChain provide to you by not taking care about everything else that is coming from your particular API. So for example, here I'm using the Mistral AI, I'm using an open AI model. I can use a Google model if I want, Gemini that has been explained in the previous talk. All this thing has been abstracted by LangChain in such a way that you don't care about their own respective implementation. It is possible to be able to do what I've just done here, but it will be quite complicated because Mistral API has its own API, OpenAI has its own API, which has a different interface from each another, and that's why can make it quite complicated when it comes to switching between one and another to memorize the conversation and all those stuff. But by taking advantage of what LangChain can offer to us, we can be able to build complex application with less efforts. So that's basically it I wanted to cover in this particular session. There is a lot of stuff that we can cover when it comes to build an application. So one disclaimer, this library that I'm using is not, it doesn't support everything that's the Python version of LangChain support. It's still under the developments. So that's why, for example, when you go and you try to use some feature, you may not have the exact same behavior like the one that we used to have when you are using directly the Python implementation. So that will be basically it for my session. So I don't know if there is question.
Amazing, amazing. That was super informative. Learned a lot. If you have any questions, please feel free to post them in the chat section. But for now, I don't see any questions that have been posted. So I'll go ahead and thank you, Eric, for such a great session. It was very elaborate. Guess as well. Thank you so much for the session, and thank you for even taking the time to do this 4 week sessions with us. You've been there all throughout all the sessions. So just as a reminder, these sessions were supposed to equip you with the necessary skills to participate in our upcoming hackathon, which is happening on the 16th, this Saturday. So please feel free to go to the GDG Nairobi website and just register for the event. We have limited slots, and also we'll be closing the registration, I think, in the next few hours to enable us to plan appropriately for the event. So yeah, once again, thank you also to all the attendees for joining all the sessions we've had so far. And we hope that you have learned, and please make sure to go back and rewatch the videos so you can internalize some of the concepts that have been shared. Yeah, so thank you everyone, and have an amazing week ahead.
Thank you. Bye.
Oh, there's a
Thank you.
question. Sorry, Eric. How can you test this on the real phones?
So basically, I was testing on my real device that was mirroring on Android Studio. So I hope that answered the question.
Yes, it does. It does. Thank you so much, and bye, everyone.
Bye.